forms and things too. One form. Alrighty then. We are leaving behind some of the really out there stuff with special relativity, and going to, I know I really enjoy that topic, but we're going to another topic that you also cannot see, but at least you can feel and you have some experience with, and that is electricity. So this unit we're going to start by looking at the source of electricity, and then we're going to move into circuits, which is basically how we harness electricity to do our bidding, be it evil or otherwise. Yes, almost certainly, unless you don't want to. Now this, someone has created a recipe for disaster up here, because inside the white PVC tube was a copper tube, and inside the copper tube was a glass rod, sort of like a turducken, except the duck doesn't shatter when you drop it. So please don't put the glass ones in anything. That is actually, I would have been telling you that even if had no one made me think of it right away. But every year we lose one of those. We've lost one already with my 9th grade class, and I'd rather not lose another. But it's not always just the freshmen.
Now that you said that, we'll probably shatter like 4.
Please don't. So when you set it down, just make sure it won't roll off somewhere, and don't put it inside anything else.
Otherwise, have really good reflexes.
What we are going to be doing is a very, very early experiment that was done with charges, long before we knew as a race what charges were, where they came from, or anything like this. One of the people who liked this stuff best was Ben Franklin. He used to jerk people around by saying, "Hey, touch this." And then they'd touch it and they'd get a huge shock and stuff like that. Which I admire him for. But what we're going to be doing is seeing, one, how charge can be changed, taken from one thing and moved on to another. And that usually involves some sort of friction. So you're familiar with this, walking across a carpeted floor and then touching something, another person or something metal or even just getting close to it, and you get the zap. So that's actually a static discharge. Does anyone know what the word static means? To stay the same. So static electricity is actually the stuff that doesn't discharge. It's the stuff that you put on something and then it stays there. Usually that's accomplished by some sort of friction. So I've got friction between the PVC tube, which are the white tubes, and my cat hair. Fur here. Is it fur or hair? How can you tell the difference?
Hair grows.
Hair falls off.
But fur only grows to a certain length. Thank you, Tom.
I know that because my dog, I have 2 dogs, and one has hair.
Is that right?
One
Is
has
a
to get
poodle?
haircut.
A poodle has hair?
No, it's a short.
A shorkie?
They're like hypoallergenic.
It's my mom's dog, I don't know.
Okay, good. I was going to say that.
My dog's a Brittany.
So that's what we want.
Oh, that's much better. It's a dog called Brittany. Okay, and so what we're doing with this is Lab 7.1, spin that charge. We're going to be looking at what happens when you bring different materials close to things that we have supposedly charged. And so the first thing here is as it says in the instructions, for the first time through all of this, I'm just going to keep this piece of PVC with the furry end right over there. Try and keep track of which end's furry and which end's not. Some of these are marked on the edges. We've tried with markers to color them and things, but it just comes off on the fur. And even the stuff on the end wears off. So if there's something like that, you can use that to help you remember. Otherwise, just try paying attention. Now, with each of these things in our list, I want you to rub that material with fur or not and bring it close. So the first one there that's already partially filled in is more PVC and fur. So this is a second piece of PVC. These are the things that I want you to bring close to the hanging piece of PVC, already rubbed with fur. So if I rub PVC with fur, I'm going to put the same charge, whatever that charge is, on these two pieces of PVC because they are identical materials and I did the same thing to them. So if they are charged, they should be charged identically. What happens if you bring two charges that are the same close to one another? Okay. And we can show that pretty quickly. I know it's not the force. Okay, so I would write down in reaction of furry PVC that it's repelled. I'm giving you this one as a starting point. That means that these two are negative. We, of course, know the source of charge now is electrons and protons. But back in the day, they didn't, of course, even know what an atom looked like or was, or if they even existed. Mm-hmm.
So that means is that the one on the hanger thingy? Yeah. That's always negative, so that's how we can tell.
That is always going to be negative, exactly. So if you bring something there that repels, you must have something in your hand that's negative. What if you bring something close that attracts it? Must be positive. So what I want you to do is go through this list of other things and then record the reaction to this furry piece of PVC. If you feel like it's not enough of a reaction anymore, you can certainly take it off, rub the fur on it again, and place it back. But don't touch that end unless you're giving up on a measurement, right? So once you rub it with fur, try not to handle that end at all. And don't tap these together either, because that can change the charge distribution some as well. With these that it says no rub, I mean no rub with the fur. What you'll actually do is wipe off any excess charge with your hand before then performing that experiment and trying. It might be easier in retrospect to actually do those first before you rub them with fur.
That makes too much sense.
Well, I'm getting there. Thank you for leading me to that question. Now, there will be a bunch that, or several anyway, that come up positive. What I want you to do is verify that those are in fact positive, because if two positive things come close together, what should happen with them? They should also repel. So let's say that you figure out that the PVC no rub and the acrylic plus fur both test as positive. Well, then we kind of have a no rub situation there. You could take the acrylic and fur and bring it rub it with fur and bring it close to that. If they are both positive, they should repel. So in your verification notes, you would then say for the PVC with no rub, it also repels from fur, and that's what the proof would be that it's positive. If you get some other observation, make sure to note that as well. Okay, and then there are some questions that lead you through some of the thought processes on the back, but I think the front is pretty self-explanatory. Ideally, we'll even get to the point in this class where we would be able to discuss all of this today and the findings. So if we get there, that would be wonderful. Each group working on this, let's keep it down to like 4 or fewer. We'll need 2 pieces of PVC, 1 of the glass rods, be careful, 1 copper tube, and this is the acrylic rod, which is a clear plastic. And then you'll need a piece of fur and 1 of these hangers along with the arms. The stands are in the back corner.
Who gets to use that one?
I don't know.
Me. Yes.
He rolls a die.
Yeah, I'll roll the die for you. We have 18 students, which means a roll of 19 or 20, no one gets it. Number 3.
That's the second time in a row. Okay.
How does
It's
this
you?
fix?
Yeah.
Randomize this. I just start from that corner. 1, 2, 3. If it had come up 5, it would have been you.
I see.
But it was 3. Okay? All right, grab some materials and go.
I feel like that's a little